Hello friends, I'm Ram Lakshmanan, architect of yCrash. So in this session, let's talk about Java synchronized method, right? To make this session a little bit interesting, I've put together a fun example. I'm thinking it is fun. You guys can say whether it is fun or not, okay? Okay, so let me show you that sample program. So here is the sample program, right? It's called as a synchronization demo. It has a class called synchronization demo. Within it, there is this main method, which is an entry point. Here, if you see, I'm creating like a 10 boyfriend threads, right? Here I'm creating a 10 boyfriend threads, and then I'm launching them, right? I'm saying thread.start. I'm setting the name for the thread, saying 0, 1, 2, 3, 4, like a 10, I'm giving the name, and then I'm starting it. So what does this thread does? Like look at the boyfriend thread. This is the run method, right? Here it says meet. It's invoking the meet method on the girlfriend. There's these boyfriend threads, they want to meet a girlfriend, right? Girlfriend thread, but they're all trying to meet the same girlfriend, right? It's one girlfriend object. Like all these 10 threads are trying to meet that one girlfriend object. Let's see what this meet method does. Okay. So meet method, what it's doing is it's just saying it is getting the name of it's just printing, saying the meeting started with this boyfriend 1, and then it's just sleeping for 100 milliseconds. I'm putting this thread to sleep for 100 milliseconds for 2 reasons. One, when this is going, so that when it sleeps, I can capture some background diagnostic information, which we needed for our discussion. And also during the meeting, that maybe this meeting is lasting for 100 milliseconds, right? That is for 2 intention. And then after that, they're saying the meeting completed with this boyfriend thread, right? With this boyfriend. So that's all the sample program, right? Let me now go ahead and let me execute this program. Okay. Okay. See, okay, I executed this program. Look what has happened, right? Here it says the boyfriend 2 meeting started, right? It says meeting started. There's only one girlfriend, right? But there is 10 boyfriend threads who's trying to have a meeting. So the boyfriend 2 meeting started. While that meeting is still in progress, the meeting with boyfriend 0 also started, right? So similarly, the meeting with boyfriend 1 also started. Look, it has started. See, where is this meeting boyfriend 2 meeting ended? Boyfriend 2 meeting ended. Let's look at this. Okay, see, it is ending only here at the end. You guys see? So before this meeting ends with this boyfriend 2, so many other meetings started and ended. It is going on. Do you guys see what's going on here? So similarly, look at this. When the meeting with this boyfriend 2 is still in progress, the meeting with boyfriend 0 started. Right? And that means this girlfriend is having meetings with multiple boyfriends at the same point in time. It's going to be very confusing to her, right? She's very poor girlfriend. We need to save her, right? Is this making sense? Is this example making sense to you guys? Or do you guys have any questions?
No, no questions.
Okay. So we need to...
Girlfriend is very talented.
What are you saying?
No.
It looks like girlfriend is very talented. She is handling 10 boyfriends at the same time.
Oh, yeah, but it's very confusing.
She is not intelligent.
Yeah.
So what we will do, we need to help her, right? So now what we will do, we will make this method as synchronized method. I'm introducing this method to be synchronized, right? I made it as synchronized. Now let's rerun this program, right? Now let's rerun this program. Okay, see now we launched it. Let's look at the output. Okay, see now the boyfriend 0 meeting started, and then the boyfriend 0 meeting ended. So it started, the meeting with the boyfriend 0 ended, and then only the next meeting with the next boyfriend is starting. Boyfriend 5 meeting started and it ended, right? You can see them sequentially happening, right? So this should make our girlfriend at ease, right? So this is a good thing.
Smart. This is smart.
Okay. So what is happening behind the scene when I introduce the synchronized? What is making this method to be what is making? So what is happening here is when multiple threads are coming in. Earlier, if the method was not synchronized, right, multiple threads would be allowed to enter this method concurrently at the same point in time. So when multiple threads come in, okay, we are seeing this meeting started with that friend, and then other thread is also coming in, and then we saw that mixed up response earlier in the earlier run when we executed. But now when we said synchronized, what is a JVM does is when a thread comes in, when one thread comes in, it acquires the lock of this girlfriend object. See, each object has an underlyingly lock. So when boyfriend thread, in this case boyfriend thread 0 comes, he's the first guy to come and hit this meet method. When it executes this meet method, it's going to acquire the lock of the underlying object. Once it has acquired the lock, this lock will not be given to any other threads, right? So once this acquired the lock, and when this thread, boyfriend thread 0 is executing this method, let's say if another thread comes, say boyfriend 5 comes, he wouldn't be allowed to enter this method. He will be waiting outside, and he will be put into the blocked state. This is when a thread enters into a blocked state, because the boyfriend 0 has acquired the lock and it is working on this method, meet method. So until it exits this meet method, the boyfriend 5 or any other threads who is going to come, they are going to be in the blocked state. Okay, see, only after this boyfriend 0 method exits, boyfriend thread 0 exits, other threads is going to come in, right? So this is how the JVM protects from meet method from multiple threads coming and executing it concurrently, right? So now what we did, when I ran, let's see what happens under the hood, right? I explained the theory, but let's see what happens practically under the JVM. To do that, when I executed this program, I used this yCrash open source script to capture a 360-degree data. It captures a 360-degree snapshot data about this entire stack. And then from that, I took a thread dump and I analyzed with the fastThread tool. That's what we'll look at it, right? Okay. See, here at the very top, you guys see, it has multiple sections, but I'm just going to only talk about the section which is related to us. Here you can see there is 9 blocked threads. I captured this thread dump when this program was executing, right? So there is 9 threads, 9 blocked threads are here. So what are these 9 blocked threads? These are nothing but these threads which were waiting to acquire the lock, right? And now this also has a kind of a transitive dependency graph, right? Okay, here it shows that, oh, this object, there is this girlfriend object, whatever we are seeing here is blocking 9 threads. It is reporting. And say, here are those 9 threads. 1 to 9 threads it's reporting, right? And this is telling, like, these are all the threads which is waiting to acquire the lock. And this is the guy who has acquired the lock. So it presents that. It's kind of a transitive dependency graph. Now let us say this boyfriend 1 is basically, is waiting for the lock, right? He's being in a blocked state. Let me click on it. Okay, now I clicked on it. You can see it's printing the stack trace. See, this was launched. This thread was launched by this run method, right? The synchronization demo.java line number 10, which is nothing but whatever we saw there, which is nothing but this one, line number 10, right? This is where it started, meet, okay? And then from there it progressed. And now you see it is now trying to enter the meet method. But to enter the meet method, it's a synchronized method. In order to do that, it has to acquire the lock. And you see, so that's what it's printing here. It is saying it is waiting to acquire this lock because there's some other thread who is already working on the meet method. You see, what is this number is nothing but it's called as an hash ID or object ID, right? Each and every object in Java has an underlyingly an ID. So it prints, oh, this thread is waiting to acquire the lock of this object ID, right? This object ID. And this is that girlfriend thread. Okay. So now it is saying it has gone to the blocked method. So this is the case of all these other 9 threads, right? But now let's look at this guy. the guy who has acquired the lock and who is executing the meet method. Okay, now look at it. Now this guy also started with this run method, and now, but here is a very important difference you want to see. You see, it says it has acquired the lock. It says it has locked this object, the same object ID what you saw in the earlier thread, which was being blocked. And then it went on, and then it went on to sleep method, right? Because we're putting it to sleep, right? So this is what is happening under the hood. Okay. Is this making sense, friends? Do you guys have any questions?
No questions, Ram. It is clear.
Okay. Okay. Thank you, guys. We are going to talk about more synchronized Java concurrency in our other videos. You're welcome to watch them. Thank you, friends.